Agile methodologies focus on, I hope I don't offend anyone, prioritizing features. So that's an iterative process, right? So we go through that process, we deliver the feature after we figure it out, what it is that they want, and then we've delivered code that was like a science experiment. That's great. That's when we go back and we clean up our technical debt, right? Except that under Agile, the next thing that's prioritized is not likely to be cleaning up our technical debt. So you need discipline in order to manage your technical debt following Agile practices. That technical debt is a lower priority than delivering the next feature until everything falls down. Here's kind of a typical development curve, development cost curve, effort curve. We get stuff out as quickly as we can, as cheaply as possible. We want to fail fast. We hit release, and then I like to say that all startups fail. You know, like if you round it up, all startups fail. But if we're lucky and people like our stuff and they use it, well then that's great. Hopefully our systems don't all fall over as soon as we get like nice traction. But very often they do, and we start refactoring and we get this second bump in our curve. What I shoot for with our teams is that I want to hit initial release and have my development costs go down. I want to have that long tail of maintaining the software be a fraction of the cost. I want to have code that doesn't rot. I want to be able to trust that when I ship it, it works. If we manage that anti-value and we deliver value, then we can deliver quickly. We can prove our value and have that success. We can get our widespread adoption. We can not fall over. We don't significantly refactor or rewrite our code. And we can provide innovation around what we've already delivered. Everyone who works for me knows that this is my mantra. A bunch of people here at OC Tanner have heard this from me about, 3 or 4 dozen times. Simple, demonstrably correct code. Before we can talk about simple, though, let's talk about complex. What is complexity? I don't suppose a room full of Rubyists have heard of Sandy Metz. One of her rules is, methods should have no more than 5 lines of code. More than that, you start to risk complexity. Complexity is the interrelationship between our code, the coupling between our code, the degree to which one piece of software is reliant or dependent on another. Complexity is the enemy of reliability. Dijkstra, simplicity is a prerequisite for reliability. Dan Geer, the central enemy of reliability is complexity. Tony Hoare, the price of reliability is the pursuit of utmost simplicity. Complexity is any part of our code that isn't beautiful. I love elegance. I want my code to be beautiful. I want my interns to write beautiful code. Buckminster Fuller. When I've finished, if the solution isn't beautiful, I know it's wrong. The last thing I want to say about complexity is that code is complexity, and complexity is code. No Silver Bullet by Fred Brooks. He says that complexity of software is an essential property, not an accidental one. If we could deliver the value that we set out to deliver without writing any code, why wouldn't we do that? Pretty much all of the code that we write is complexity. So we want to manage that. We want to manage that because complex code is difficult to reason about, both informally, looking at the code, being inside of the code and looking around, and formally. It's difficult to test. It's difficult to know whether or not we tested the right stuff. And we might think that our code is correct, but it's actually still difficult to trust complex code because there's so many different paths through it. So I use what I call the simplicity test. And I use this for a section of code under review. I use this for looking at libraries or frameworks. I use this for evaluating programming languages or even programming paradigms, object-oriented versus functional programming. Can I reason about the code? Can I demonstrate that the code is correct? And can I trust it? And I want to be able to say yes to all three of these things. I've been programming since 1980, professionally since 1991. I've shipped code in over 35 languages. Most of the languages I've used feel like they were created in somebody's garage. There's a reason for this. They were created in somebody's garage. Some of those garages were really big. I can think of one, at a company that's named after the rising sun or something. They have many abstractions, but the abstractions are kind of concrete. Sometimes it feels like the constructions are just like duct taped together. The abstractions are duct taped together. Some languages even take pride in how there's more than one way to do it, with apologies to Larry Wall. A lot of languages, they don't even want to pick a paradigm, right? We're both imperative and object-oriented, procedural and object-oriented. We're both object-oriented and functional. Lots of choices, right? Frameworks and libraries are created generally to add new abstractions to a language, not to simplify the language. So now we've got a new tool, a new abstraction on top of the abstractions that the language itself is exposing, and we have to master the abstractions in the language and now the abstractions in the framework as well. Just look at React on JavaScript with Flux versus Elm. Elm gives you just the abstractions, pretty much, that React and Flux gives you, without the abstractions from JavaScript. Using these languages means that in order to have good judgment with them, we have to master the language. We have to master the whole language. Otherwise, you're using the tools in the language that you're familiar with. And I think I saw something about using a coffee cup to hammer a nail a minute ago. There's a lot of flexibility in that, and that flexibility feels like freedom. And I'm going to suggest freedom is slavery. Thank you, George Orwell. Other languages feel like they're based on the laws of the universe. And there's a reason for that. They're based on the laws of the universe. They have fewer, but more solid, more abstract abstractions. They're based on math. They're based on logic and philosophy. They are usually based on lambda calculus. Few of them are based on combinatorial logic. They usually add in type theory, set theory, category theory. And we just covered almost all of the functional programming languages out there with those 4 abstractions. 5 if you include combinatorial logic. This is kind of constraining. We don't have that freedom that we're used to. I love the t-shirt that says my compiler compiled your compiler. That's really powerful. But I'm not going to drive a semi-truck to go pick up a dozen eggs. I like my teams to have constrained languages. There's less to master. They can accomplish more quickly because they can master the whole language. I have interns working for me, and I never teach interns one language at a time. They always learn at least 2 languages at a time because I want them to learn how to abstract what they're getting from that right off the bat. And that works great. In the first month, I have interns who can program in Elm and Elixir at the same time. work front end and back end. With more constrained languages, my juniors can deliver value more quickly and more consistently. And I love that. I love the fact that we have a 3-tiered organization on my team. I have the lead dev who's responsible for architecture and design and security and everybody's code. All of the code on the project is his responsibility, Michael. My seniors are responsible for their own code, but they're also responsible for the code of the junior that they're paired with. And we don't do 100% pairing. That depends on the junior and senior. I don't like to tell juniors or seniors that they have to pair all the time. They're welcome to. I love it when they do. But the seniors are responsible for the junior's code. The way that they do that, first and foremost, is that they are supposed to make sure that the junior understands the theory behind what they're going to work on. A senior assigns a discrete task and makes sure that they have theory first. And we've heard about boot camps. I work pretty heavily in gender diversity in tech. My team is 60% women. I think we hold the record now in Utah. And it's really easy. It's hard to find a senior who's a woman. There aren't that many of them. I've met people who have gone through hundreds and hundreds of resumes and never seen one from a woman. I have a rocket scientist on my team. She's amazing. Got a degree in aeronautical engineering from MIT. Did 8 years at Lockheed Martin. Took a couple of years to work for a startup, designing hoverboards. And now she wants to work with big data. She's my junior data scientist. She came on as a junior for the opportunity. That's not going to last. The junior part, not the her working with us part. Junior developers, it's easy to find women who want to get into it. And with the tools that we're using and the structure that we have, it's really easy for those juniors to move forward quickly. My current goal is to learn how to take somebody who does not have a degree in computer science from intern to senior as measured by value delivered, not lines of code or years or hours or anything like that, in 4 years. I have one woman on my team who was an intern in December, and I'm going to be really hard pressed not to make her a senior inside of 12 more months. She's running her own project right now, and not only is she running her own project, including product on it, but she went to the big users conference 3 weeks ago, worked the floor the whole time selling her product, meeting with companies like Target. She kicks butt. That gets us to the tool that we use, functional programming. I'm only going to go through some of what functional programming is. It's not a deep dive, because I want to do code. But this is how I describe it to new developers. And by the way, I mean, it's not just my team. I teach workshops all over the world in Elixir. I love the fact that I've taught several times now in Krakow, which is the home to Jose Valim. He's from Rio, but he and his wife live in Krakow now. And I work with groups like Girl Develop It and Women Who Code and Carrots and Girls Who Code. So almost all of my workshops are designed for women who have not yet worked as a professional developer. And I've had Jose Valim, creator of Elixir, Bruce Tate, the author of 7 Languages in 7 Weeks and 7 More Languages in 7 Weeks. I've had Robert Verding, one of the creators of Erlang. I've had all of them stop in just to say hi to my students, people who have not yet worked as a professional developer. It's beautiful. This is how I describe it, functional programming to them, or pure functions to them. First one is referential transparency, right? Referential transparency means that a function is going to return the same result if given the same arguments. f of x equals x squared is always going to give you 4 if you give it 2. Another way of saying that is that any pure function called against a given argument can be replaced with the result of that function call, and it doesn't change the meaning of the program. So it doesn't matter if I say, if f of x is x squared, and I have f of 2, I can replace that with 4, and nothing changes in the operation or meaning of my program. Another way of saying that is nothing about the state of the program can change the result of my function call. This makes it really easy to reason about what your code is going to do. Second thing I like about pure functions is that you can do function composition. You can string the functions together to make new functions. Anybody ever work in Forth? Yay, I love it. Like, what, 4? Forth is wonderful. It lets you define new terms based on existing terms. And you do that all day long until, you've made one term called main or whatever you want to call it, run, and it is made up of all of the other terms that you define, which are made up of terms that you define, which are made up of primitives. And it's the same across functional programming all over the place. We do this in non-functional languages too, but that function composition gives us multiple levels of abstraction for our program, for the domain problem that we're trying to solve. And it gives us the ability to move up and down that abstraction tree, so we can look at it at the top level, get the big picture, understand what's going on. We can use the ubiquitous language from our problem domain when we're defining these functions. Makes it easy to read. It makes it so that our business partners can read our code. Has anybody ever experienced that? Product comes down and says, oh, I see how you did that. Isn't that beautiful? The third thing I like about functional programming that I think is really important about functional programming is immutability. Immutable variables, which the first thing I always think of is invariable variables. It doesn't make any sense. I actually have shifted. I don't think of them as variables anymore, and I teach other people not to as well. If we have functions that have referential transparency, you give it an argument, you always get the same result. Well, what if you had a function that didn't take any arguments, and it always returned the same result? And that's how immutability works in functional programming. And in fact, early in the days of functional programming, that's how it was coded, too. The last part that I think is important to understand about functional programming is state transformation. It's not like in SQL, where you say, hey, update this, and we destroy what used to be in there, and now we know what's there now, but we only understand the current state. Same thing that happens typically with object-oriented programming. When you use a setter, you know what the current state of your object is. You know the current identity. Functional programming, we don't actually do it that way. We take our existing state, apply some functions, and we get a new state. We transform one state to the next. So in object-oriented programming, we can look at identity of an entity in our domain as the current state of the object. In functional programming, we can look at identity as a collection of states over time. You can look at me now and say, hey, this is my first experience of Rob. He's like this, he's this tall, he's this old. He's got, a braid or whatever, a pink lanyard. And, that's my current state. But I'm not just my current state. I'm kind of the product of everything that happened up to me, right? And this is true of any of the entities that we're working with in programming. Because the state is immutable, we get this for free. We don't mutate our state from the previous version to the current version. We automatically always have the current version in the next version, or the previous version in the current version. We choose what we throw away. So if we don't choose to throw anything away, we actually can have all of the versions across time. Time variant understanding of identity of the entities in our domains. So identity in functional programming is an immutable, append-only collection of states over time. I hope you don't mind that I attributed Pocahontas to Rich Hickey. He's the creator of Closure.
Close.
Close. I'm pretty sure he said it. I work with other people to do functional first programming. I like to think that the lowest hanging fruits from functional programming are not limited to pure functional programming languages. And if that were the case, we wouldn't have things like Scala. But really, in almost any programming language, we can borrow from functional programming. Eric Evans, who created domain-driven design, I don't know this for sure, but I think that he was probably influenced by functional programming in creating domain-driven design. I'm pretty sure that he was trying to take some of the lowest hanging fruits from functional programming and apply them to architecture. And it works. And domain-driven design actually maps really, really nicely to functional programming. Works well for object-oriented programming, but I love it with functional programming. So with functional first programming, which we can do in any language, we're going to do it in Ruby in a minute, we have a couple of options. But really the easiest thing is code everything you can without any side effects and then code your side effects. Isolate your side effects completely. And side effects, obviously we need side effects. A program that doesn't do any side effects is just a black box. All you could tell is that the box gets hotter. Simon Peyton-Jones. I think that's wrong. I think heat is a side effect. Side effects are assigning a value to a variable. It's kind of the difference between imperative and declarative language, right? If I'm in an imperative programming language and I say x equals 0, I'm saying set x to this value 0. If I'm in a declarative programming language and I say x equals 0, I'm saying, hey, there's a relationship between these two things, x and 0. They mean the same thing. I have kids. Anybody have kids? I have an autistic child. We do a style of therapy with them called relationship development intervention. And one of the most important things I learned from RDI is that as adults, when we interact with kids, if you look at our language, 80% of it is imperative. Close the door, pick up your shoes, eat your vegetables, go to bed. Go to sleep already. If we did that with other adults, there's a name for that. I'm not going to repeat it here. With other adults, 80% of our language is declarative. We share our experiences. The way that that works with the child, especially children who are under therapy for autism and similar conditions, is it forces them to use their prefrontal cortex in a way that helps develop it. We do the same thing as programmers. Prefrontal cortex is where we develop the ability, have the ability, to keep track of social networks. Dunbar's number, originally published as, 150 people that you can maintain meaningful relationships with at any one time. I'm not suggesting that you're dating all 150 of them, in case you were wondering. Later, he did another study, Robin Dunbar, demonstrating a correlation between the size of the prefrontal cortex and the number of relationships that we can manage. In that study, he was able to demonstrate anywhere from 90 to 220 depending on the size of the prefrontal cortex. Those relationships in the real world that we manage are the same ones that you and I all manage in our code, too. We're constantly looking at how different parts of the problem fit together, how different parts of the code fit together. All of those connection points and interfaces. Declarative language helps the child develop that. I'm going to say that declarative language helps us develop that, too. So if you program in functional programming, you'll get more dates. Okay? Good. Other side effects, telling the time. You ask a computer what time it is, you run a function that gets you a different answer every time, depending on the granularity of your clock. Getting an API request is a side effect. Reading from a database or writing to a database is a side effect. Responding to an API request is a side effect. Rendering something on the screen is a side effect. Adjusting the ailerons on an intercontinental ballistic missile is a side effect. It's a pretty big one. Side effects are basically the opposite of referential transparency. With referential transparency, you put one value in, you always get the same value back. With side effects, you put one value in, you may or may not ever get the same value back. So functional first programming's plan is pretty simple. Just code everything you can without side effects and then go back and put in your side effects. That keeps your side effects at the edges. It isolates your side effects. It gives you pure functions in the middle, which does a lot of really cool things for us. It means that for those pure functions, we can almost always just use the core language. Maybe a few libraries, like date and time calculations, right? Stuff that we don't want to write ourselves, but we're not talking about huge frameworks that are going to bloat out our code and significantly increase our complexity. When we're in pure functions without side effects, we don't need I/O libraries. Our code bases are smaller. It's a lot easier to reason about. It's way easier to test, and it's fast. We don't have to mock anything. Is there anybody here that loves mocking? Good, because if you raised your hand, I was going to mock you. Our logic is stateless, and it's really easy to scale our programs horizontally. That also means that almost all of our side effects, well, they're based on I/O. And we don't usually write our own I/O libraries, which means we probably don't have to do any unit tests around them because our I/O libraries come with their own unit tests. And if our side effect layer is only doing side effects, then we don't need to test that with our unit tests. We can trust their unit tests and our integration tests. The thinnest possible wrapper around our logic gives us that side effect layer, which means that it's really easy to switch it out. I don't want to use MySQL anymore. I'm going to go to Postgres. Oh, look, I only have to replace 30 lines of code. I've got an HTTPS interface, and now I want to add, a message bus on top of that. It's super simple. It's just wrapped around the same business logic. Okay, so let's imagine a shopping cart. Anybody ever written a shopping cart? Okay, good. Yeah, like a third of us, right? Typical shopping cart. Let's go through that. Okay, so I am gonna put some organic Twinkies in my shopping cart. Great. I have organic Twinkies in my shopping cart, right? I need to buy some elephant food. This is true. I have an elephant. She's a dog, but my son, when I emailed him and said, we email back and forth all the time. I emailed him and I said, hey, I'm thinking about getting a dog. What kind of dog do you think I should get? He wrote back and said, no dog, elephant. So I need some elephant food. I've got elephant food in my shopping cart. I need some toenail polish, in case I wasn't wearing socks today, right? Great, got the toenail polish. I need a cummerbund, because I was gonna dress up for you, but it didn't work out. Then I realized that the toenail polish I got from the elephant aisle. I don't want elephant toenail polish, so I'm gonna take that out of my shopping cart. Gonna put in 2 hula hoops, and some hydrofluoric acid. If you've watched Breaking Bad, you know why you need that. Oh, but then I realized one of those hula hoops was for my elephant. It's never gonna fit her. So I gotta take out one of the hula hoops, right? So that's our typical way of doing a shopping cart, or a SQL database, or state in an object. It's destructive. You can't tell me what was the third thing that I put into my shopping cart based on what you have in the database. You can't tell me how long the toenail polish was in my shopping cart from the right-hand side. I had to think, this is my right. Yeah, it should be your right too. But if you look at the events instead of the current state, you can answer a lot of really interesting questions about my shopping behavior with that shopping cart. Obviously, like one simple question is what's in the cart? And that's what we have on the right-hand side. But we can answer other questions, like how many people put that new Ferrari in their shopping cart on Amazon and then take it out before they check out? And how can we increase sales on our Ferraris? Let's do some code. If I can figure this out. Where's, okay. Sorry, it looks like the, yeah, it's also going off of the edges. Yep. Okay. I thought about doing this with mob programming. There's what, 150 of us or so. Do you want to do mob programming? I'm going to pass. 6 minutes? Is that what's left? Ooh, okay. Well then, let's do some Ruby. Is this big enough for people to see? Whoops.
Maybe go one side.
Yeah, because I can't quite see it on that screen. Okay. I'm bumbling that, huh? Huh? Yes, you're right. Yeah. Don't. Oh, thank you. Yeah, this is why we don't do live coding, right? Like I said, I'm not much of a Rubyist. Let's see, I think I can get rid of that and get rid of that. And now it should let me do bundle. Oh, I need Wi-Fi. Yep. Good. Okay. Does something useful, but not really. I'm going to go a little bit quick and you got a problem with that?
We don't.
What? Okay, so now we've got, I thought I'd keep it simple. I'm sorry, I didn't realize there were going to be so many Emacs people here. So it knows what's in the cart, right?
Must all be in the room.
So I've got an undefined local variable called what? Cart events, cart test events. So to get that to work, I'm going to need to require date. Whoops. And the same events that we just went through. If we run rake spec on that, then it says what? That got it. Yeah, I mean, it's great that you guys can read this up here. I feel like I'm too far away from that one. And I need my notes because I'm not a Rubyist. Okay, so we, okay, so we have undefined method from Ruby cart module. So we'll put that in. Right? Right. Rake spec. We've got no content reducer, so we need that. Okay, does this look familiar? Is this fairly standard? We're using reduce. It's like definition practically of functional programming for non-functional programming languages. We don't have any data in here. It's not a class. No data structure here. Our data structure's coming from the test. Rake spec will tell us now that we still need to know what the cart is supposed to look like. That's what we got from that example. Do a rake spec, and everything works there. So all we've done is said, hey, I've got this data structure that's a list of hashes of events, process those events, reduce them down. We call that a reduction when we're talking about it from the programming side, or a projection when we're talking about it from the data side, because our data is really rich, right? So it's kind of like a silhouette. It's like the light is shining on the events that tell us everything and coming up with just one outline of it, a projection. And we get that with a reduction. And that reduction gets us that shopping cart, just like we would expect. Oops. So let's do the same thing now in Elixir, because it's going to look really, really similar. I did a mix new, got me a new project, run the test. We're all good to start with. Okay. 3 minutes. Oops. So we've got a test, just like we did for the Ruby version. We know what the cart should contain. See, this is just slightly different than what we saw in Ruby. We're piping it to enum sort. And we've got all of our events. In this case, we're not using a hash, we're using tuples, but same difference. Run mixed test, and apparently I have an eye again, huh? Yeah, who made this Vim stuff? Cool, we have a failure. Undefined cart contents. So we'll go over to our code. No, I don't. Again, we're just going to do a reduction here, but again, we're piping. We start off with the list of events that's sent in, we're doing a reduction against it, and then we're sorting it, right? No assignments. I'm going to skip. Obviously, I'm not doing much on the test there. I'm going to skip the test for the one test for a second and just implement the content reducer. Elixir lets us do this nice thing with pattern matching. So that tuple, we're using what Elixir calls an atom. You see it in Ruby as a symbol, right? And we're saying, hey, I've got either an add or a remove. If I've got an add, do this. If I've got a remove, do that. And the code probably looks more or less familiar to you. It's about 10 lines shorter than Ruby code. And I think I find it easier to read. And we're basically doing the same thing. And now if we run our test, everything passes there. Obviously, we didn't write edge cases. We only wrote a happy path. We really should have, I should have done better testing. We don't have persistence. When you're dealing with a lot of events, you probably want to keep your model and just apply the new events. But the next thing I would do, of course, is use this code inside of Sinatra or Phoenix or Plug, and I would just call the business logic in with the I/O wrapper around the outside. I would even, if I'm persisting my models in that wrapper, I would pull in the model from the database so that my business logic is just getting the starting model and the new events. And that business logic now can work regardless of where I'm storing the model, regardless of how I'm getting the requests, where the events are coming from. And that's it. The question was, how did I find myself getting into functional programming and this? In 1999, Erlang was open sourced by Ericsson, and I read a little bit about it, and I thought, oh, that is the most amazing stuff ever. I want to learn that. 8 years later, I figured out I was a really, really lousy programmer, and I had to fix that first. A few years after that, with a whole bunch of meetups and conference talks, I had learned about being an expert beginner, where you're always the top person, but there's nobody else around or nobody who can challenge you, and figured out why I was a lousy programmer and fixed it. And then around 2011, I started learning functional programming, and that only took me 2 years, seniors. Like I said, why functional programming matters is a really, really important paper. And for those 2 years, I did not understand it. But I did find another paper called Why Functional Programming Matters, and that helped a lot.